this video will be on how to find thermal conductivity of materials. This will help you with problems 23 through 27 in your 1.3.3 activity packet. So pause the video, read through the problem, and then let's figure out what we know and what we need to find out, and then find the correct equation to use and solve. So we have a box that has dimensions 10 inches by 12 inches. It's covered with 0.6 inches of insulation, some sort of insulative material. We need to determine the thermal conductivity of the insulating material if a 45-watt bulb is used to heat the box. The bulb maintains the inside temperature at 20 degrees Celsius higher than the outside temperature. So let's list all of our known values. We know the area of the box. We have a 10-inch by 12-inch area, which is 120 inches squared. The area needs to be given in meters squared. So what we need to do is convert from inches into meters. We're going to use the fact that 2.54 centimeters is equivalent to 1 inch, or if you move the decimal over and convert to meters, we have 0.0254 meters is equivalent to 1 inch. So if we want to convert inches squared, then we have to square these numbers to do the conversion. So let's take this 120 inches squared, and if you, and you square 1, you'll still have 1 here. Okay, so 1 square inch is equivalent to 0.0254 meters squared. So we need to take the 1 squared inch, put it in the denominator, so those will cross out, and the 0.0254 squared meters squared. And when you do that multiplication, we get 3. Oh, I didn't square it. Hang on. We get 0.0774192. Okay, we also know, I'm going to run out of room here, we also know L, which is the insulative material, the thickness of the insulative material. Make sure you have your equations out so you know what all these values represent, all these variables represent. This needs to be in meters, and we know that it is the thickness of the material is 0.6 inches. So in order to convert that into meters, we're going to have 1 inch in the denominator. We're going to this conversion factor right here, and we have 0.0254 meters. So the inches cancel out. Do the multiplication. You end up with 0.01524 meters. And then we also know the power is, we have a 45-watt bulb. Those are the things that we know. So the unknown value, what we're looking for in this problem, is, pick a different color, the thermal conductivity, which is K. Okay, so selecting the equations, look at your set of equations and find the equations that deal with K, first of all, P, L, A, and then we also know, I didn't write this up here, we also, for our known values, we know that the change in the temperature from the outside of the box to the inside is 20 degrees, and that needs to be in Celsius, and it is in Celsius, so there's no converting necessary. So the equation that we're going to use down here for our value of K is P times L over A times the change in the temperature from the outside to the inside. All right, so let's put in the known values. P is 45. L is in meters, 0.01524. The area in square meters is 0.0774192 times 20. And we're going to throw that in the calculator. In the numerator, I'm going to put the numerator in parentheses. 45 times 0.01524. Then we're dividing that by, in parentheses, you have to put it in parentheses, 0.0774192 times 20. Parentheses, and I'm getting a value of approximately 0.44. And this is has units of joules over seconds times meters times Celsius degrees, and this is called the thermal conductivity. So now go to your packet and use the values in the packet to complete numbers 23 through 27.